Welcome back, everybody. We are going to be looking at lesson 9-4 today. 9-4 is on the properties of rectangles. So let's go ahead and go to our iNotebook and let's get started. So lesson 9-4, rectangles. So rectangles are a parallelogram. They are a specific parallelogram. So let's first define a rectangle. So a rectangle, the definition is a parallelogram with 4 right angles. Now notice that there is nothing in here about parallel sides. There's nothing in here about opposite sides congruent. And so I have kids that are a lot of times add those things in and they think it's the definition of a rectangle, but those things are all actually definitions of a parallelogram. So the only thing that makes a rectangle and not just a parallelogram is the fact that it actually has 4 right angles. It doesn't have anything to do with the sides. The sides make it a parallelogram. So the properties then are going to be all 4 right angles. That one is particular to a rectangle. Opposite sides are parallel and congruent. And we know that because a rectangle is a parallelogram, and that's actually a property of a parallelogram. We know that opposite angles are congruent. We know that because it's a property of a parallelogram. We also know that because all 4 angles are right angles. And right angle congruence theorem says that all angles are congruent if they are right angles. Consecutive angles are supplementary. And we know this because if they're all right angles, the 90 plus 90 has to equal 120, but also this is a parallelogram property. And so therefore all rectangles are parallelograms. We also know that diagonals bisect each other. And again, this is because a rectangle is a parallelogram. So all of the parallelogram rules fit except for this top one. And that top one is what creates a rectangle. So theorem, diagonals of a rectangle theorem. This one is special to a rectangle. And it says that if a parallelogram is a rectangle. So to prove this, you would have to prove that something is a rectangle first. If a parallelogram is a rectangle, then its diagonals are congruent. So keep in mind, in a parallelogram, diagonals are not necessarily congruent. They have to be a rectangle for it to be true. So let's go back over here to our properties page. And properties of a rectangle. So all 4 sides are congruent. That's not true in a rectangle. Opposite sides are congruent. Yes, because it's a parallelogram. Diagonals bisect each other. Yes, because it's a parallelogram. Each diagonal bisects a pair of opposite angles. That is not true in a rectangle. There are exactly 1 pair of opposite angles that are congruent. That's not true because we have more than 1 pair. Opposite sides are parallel. Yes, because it's a parallelogram. Diagonals are congruent. Okay, so there's the special one in a rectangle. Consecutive angles are supplementary, yes. Diagonals are perpendicular, that does not happen in a rectangle. Opposite angles are congruent, yes. Diagonals that intersect the opposite congruent angles is bisected by the other diagonal, no, that does not happen. And all 4 angles are right angles. So in the rectangle has 2 that are special to rectangles that parallelograms themselves don't have. Otherwise, it has all of the parallelogram properties and then those additional 2. So let's go back to our page here and we are going to go through. I'm not going to go through all of the questions because I would like to leave some of them for class time. So go through some of these. Get rid of it on this page. Okay, a rectangular park has two walking paths as shown. If PS is 180 degrees and PR is 200 degrees, find QT. So first thing we know, this is a rectangle. So therefore it follows all the rectangle rules. So if PS, so right here, PS is 180 meters and PR, the diagonal is 200 meters, find QT. So QT is from here to here. So a couple of things. One, we know that diagonals are congruent in a rectangle. So therefore QS would also be 200. And if QS would be 200, we know that in a parallelogram, which a rectangle is a parallelogram, that the diagonals bisect each other. So we know that this has to be congruent to this. PR is congruent to QS. So therefore QT has to equal 100 meters. And then it says if TS is 120, so TS, this one right here is 120, find PR. So again, this is going to be half of QS. So if this is 120, then this whole thing is going to be 240. And in a rectangle, diagonals are congruent. So PR would also be 240 meters. And if the measure of angle PRS is 64 degrees, so PRS is 64 degrees, find measure of angle SQR. So this is where the congruent triangles come in. So we know that if this is congruent to this, and this whole thing is congruent, then we know that this has to be congruent to this. So this is going to create an isosceles triangle. So we know that that is 64. If we know that both of these are 64, we know that that guy is also 64. We know that guy is also 64. So we have a 90-degree angle here. And if we have 64 degrees taken out of it, we know that we have 26 degrees left. So if that's 26, then this also has to be 26 degrees. And therefore, the measure of angle SQR is 26 degrees. So a lot of these are just the algebra behind all of the properties. So you have to know the properties to be able to apply the algebra. And we're going to leave those other two for in class. So next I want to look at the next one. And it says that quadrilateral PQRS has vertices, and we're going to determine whether it is a rectangle using distance formula. So now these are really particular. You're going to have some that say find them using distance formula and others using slope formula. So we know that we can find perpendicular lines through slope. And if you can show perpendicular lines, you can show 90-degree angles. So that gives us the ability to find out if we have 90-degree angles, which then in turn can prove that something is a rectangle. So let's go ahead and plot this first. So -5, 3, 1, 2, 3, 4, 5, 1, 2, 3 gives us P. Q is 1, -1. R is -1, 4. And S is -7, 0. Now, it is pretty darn obvious, unless I drew this wrong. 1. Oh, -1, -4. That's why, because that guy's not right. That makes more sense. He kind of looks like a rectangle, doesn't he? So it might be a rectangle, but we need to prove using distance formula. Now, I don't care when it asks for distance formula if you find actual distance formula or if you use Pythagorean theorem. To me, they're the same. Pythagorean or distance formula comes directly from Pythagorean theorem. On a graph like this, to me, Pythagorean theorem would be easier. If I just had the coordinate pairs and I didn't have graph paper, then I would probably use distance formula. So we're gonna prove opposite sides congruent. No, opposite sides congruent are only going to prove a parallelogram. We're trying to prove a rectangle. So if we want to prove a rectangle, we need to prove that from P to R is congruent to S to Q. That's what we need to do. So I'm actually, yeah, I think I'm going to use, so S to Q, and we need to find P to R. So from S to Q would be -7 minus Q plus 0 minus -1 squared. So this would be -8 squared, which would be 64. This would be 1 squared, which would be 1. So this is the square root of 65. And again, you don't have to simplify these, because if I have, it's about whether they're congruent or not necessarily that they're simplified. So if you want to leave it unsimplified, it's actually a lot more easy to compare them. So from P to R, so from P, so we have -5 minus -1 squared plus 2P to R, so 3 minus -4 squared. And that gives me 4 squared, which is 16, plus 7 squared, which is 49. And that would be 5, carry my 1, 65, square root of 65. So we can determine that PQRS is a rectangle because diagonals SQ and PR are both root 65, so they are congruent. And that's how you do that finding using distance formula. So the next one then is using finding slope formula. Finding slope, again, if you have graph paper, I don't care if you use actual slope formula or if you just use the graph and do rise over run, either one is fine. So first thing, we're gonna graph our quadrilaterals. So that would be 8, we're gonna have to go out 1, 2, so 10, 2, maybe out here. That would be J, -8, -6, be K, L is 5, -3, and M is 2, 5. So J, K, L, M. So I'm just going to do rise over run for each of these and get the slopes. So it looks like rise is 2, 1, 2, 3, 4, 5, 6. Oh, no, rise is 3. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 and 3 gives me 3 over 13, and it's positive. So KL has a slope of 3 over 13. And then ML, 1, 2, 3, 4, 5, 6, 7, 8 over 3. And that's -8 over 3. Well, that tells me right there that it's impossible that that's a right angle, because this would have to be opposite and inverse for it to be a right angle, unless I just graphed it wrong, which I don't think I did. Just checking to make sure that I didn't graph anything incorrectly. So 8 and -6. And that was 5 and -3. And so no, it is not. So this is not a rectangle because KL is not perpendicular to ML. And that's all you'd have to find. Okay, so The next one is a proof. We're going to go ahead and do a 2-column. And we know that ABCD is a rectangle. BC is congruent to DC. And that is given. And we are trying to prove that AC, so we want to prove that this guy is congruent to this guy. That's what we're trying to prove. So just by looking at it, I think we probably can prove some congruent triangles, and that would be able to use CPCTC. So I'm going to start with right angles. So I can say that angle B and angle D are right angles. And I can say that because of definition of a rectangle. Definition of a rectangle is a parallelogram that has 4 right angles. And we know that it's a rectangle. And then I can say that angle B is congruent to angle D because of right angle congruence theorem. So if I'm trying to prove congruent triangles, that's 2 of mine. I have one side and one angle at this point. We also know that AB is congruent to ED. And the reason that we know that is because of opposite sides of a parallelogram theorem. We automatically know that if it's a rectangle, it's a parallelogram, so we don't have to state that. That gives us that triangle ABC is congruent to triangle EDC by side angle side. And then we can state that side AC is congruent to side EC by corresponding parts of congruent triangles are congruent, CPCTC. And then finally, the very last part is to sketch rectangle ABCD and list everything that you know about it. So we're looking for all of those. So I'm going to make a rather big rectangle. And the rectangle has to have 4 right angles, so therefore that is a rectangle. List everything that we know about it. Well, we know that it has 4 right angles. We know that it is a parallelogram. And if we know it is a parallelogram, we know that opposite sides are congruent. We know that opposite angles are congruent. We know that diagonals bisect each other. We know that diagonals are congruent because it's a rectangle. We also know that consecutive angles are 180 degrees or supplementary. Let's see, did we miss any? That's 7. So I'm going to flip back here. We have 1, 2, 3, 4, 5, 6, 7. Yep, so we got all of them. So that's everything that we know about it. So that is all for the properties of rectangles. So if you have any questions or concerns, you want to work some more problems, I'd be happy to do that with you. Just get a hold of me and we'll work through those. So until next time, we'll see you later.